Okay, question 3. Create a standardized score for reading and math. Now this is something you should have done in business stats or in any statistics class, and that is create a standardized score. Oftentimes we think of these as z-scores, meaning we take a variable that has a mean and a standard deviation, and we standardize it so the mean is 0 and the variation is 1. So to help you understand why we do that, take a look at this golf club. All right. And so I have no idea how this relates to standardized test scores or standardized of a variable, but if you can figure out a way, let me know, because I would love to include props in these videos for the future. But since we don't have any explanation here, let's go ahead and just think of how we standardize a score. So the way we do that, so I'm going to do Alt-N-E-I, which inserts an equation. So a z-score, which is a standardized score, is equal to a fraction. On the top of the fraction is xi, meaning the individual observation of the participant of the study or the sample. Subtract off x bar. So we take the individual observation and subtract off the mean and then divide it by the sample standard deviation. So this is all we need to answer this question here, is create a standardized test score or standardized score for reading and math. Okay, so what we're going to do is we're going to take an individual student's math score, xi, so if they get 100 on this math test, we're going to subtract off the mean and then divide it by the standard deviation, and it's going to give us a new variable. So let's go ahead and try that. So let's come to our data set. Okay, sheet 1. Okay, so come here to the very top, and what you see is we have in row T and U, we have reading and math. We have other scores as well, but we're going to focus on reading and math. So the reading score, what you'll notice is this first person doesn't actually have a reading score. And that was part of what we did in question 2. So question 2, we said there's 536 people in our whole sample, or 8.5% of them, that actually don't have a reading score. All right, so that's what we want to keep that in mind. But we want to say, so this person has a 427, they have a 450, and the question is, what does that mean? How do we compare that to other reading tests that are available to other students? So the way we want to address this is we want to come down here to row T, okay, which is the reading score, and we want to come up with what we call the mean reading score. Okay, and so this is just the average. Okay, so we start at the last one, we go up, and so we're going to go from, oh, we don't want this, because this is column S, and our reading score is actually column T. So I'm going to create this in column S. I'm just going to copy and paste it over to column T. So 2 and to 6326. Okay, so I'm going to copy, paste, delete, copy, paste, delete. So my mean reading score is 436.725. So a student who got 413 is below the mean, and the person who got 448 is above the mean. So now I want to create the standard deviation of this. Okay, so if I go to here and I anchor these from T2, and I anchor this one, and click enter, and I copy paste, what you'll notice is that I get again the average here. I have the right range, but I need to change the word average to standard deviation. So it has a standard deviation of 31. So the person who scored a 413 is 20 points below the mean, which is about 2/3 of a standard deviation. The person who's at 470 is what, 35 points above the mean, which is a little over a 1 standard deviation above. So now that we have mean reading and mean standard deviation, we can do the same thing for math just by copying and pasting over. So the math mean score is 437. The standard deviation is about the same. Okay, we want to make sure this is math. We also want to make sure, because we anchored it, you notice that both of these are T. So that's not good. So that's actually not the math. We need to change that to U. Okay, so we have it from U2, great band, to U6326, and down here, not from T, but from U2, great band, down to 6326. So the mean math score is actually higher, 45, and the standard deviation is wider, so we have a wider range of that. Okay, so now that we have those calculated, let's come up here and create a new variable. Okay, let's call this Z reading. So this is our Z score of our reading. This is going to equal, all right, we're going to go to our reading score, which is right here. This person's blank, but we're going to still do this one anyways. Okay, minus, okay, and it's going to be minus, then we want to find where we did that Z-stat. Okay, so that Z-stat, or I'm sorry, the mean. So the mean is in, let's see, that is 6331, so I'm going to write that down just so I remember. That means 6333 is where the standard deviation is. So I've kind of messed this up royally over here. So we want to equal T2 minus the mean, and we want to anchor the mean, okay, divided by the standard deviation, which is T6333, and anchor that, and click enter. Okay, so that person got a score of negative 13,744. We double click and it'll go all the way down. And so now we have a Z score. So this person right here scored 1.3 standard deviations above the mean. This person right here scored 0.02 standard deviations below the mean. Okay, so now that we have this, okay, we can delete all of these. Okay, one thing we want to note is, well, why are they 13 standard deviations below? That's really far below. Is there anything unique about that? So we look here to column T. Well, that person's actually missing their reading score. So we don't want to include these people, because if we run an average of this, so we want to do the mean should be 0. So this is equal to average. Well, that's definitely not 0. And the standard deviation should be 1. And that's definitely not 1. And it's what's driving this is these negative 13s, which they really should be missing variables. So what we want to do is create another Z reading, call it Z reading 1, which now we want to replace these values if they're missing. So this is, we're going to do an if command. So equals if. So here's the key, is if reading is equal to missing. So we do 2 quotation marks for a blank cell, then comma, then if that's true, what should happen? Well, we want our Z score to also be missing or blank. And if not, then return us just the Z score that we calculated. So this person, even with the cell, is missing because that first person indeed doesn't have a reading score. I double click and now I get those reading scores blank whenever it's there. So that's exactly what we want. All right, and so now if I were to copy and paste these over, what I find is that this is 16 zeros and number 5. So if I make it have, oops, we don't want to do that. So let's go ahead and format this and to make it a number. So it's not scientific, but a number with 2 decimal places. What you'll find is that number 0 with a standard deviation of 1. So now we have a mean reading score. Okay, and so now we just need to do the same thing for math. Okay, so again, so here we have T2 and that. So we want to do the same thing, but instead of T, it's going to be U2. Okay, let's just go to the bottom, make sure. So for math, it's the same thing. So it's going to be U6331. All right, so let's come over here, call it Z math, and we can just copy and paste this over. Okay, and now we don't want V2, we want to change this by hand. U. So we start at U2, great band, and go from there. Now this person's at 10, we double click down, And then we again want to redo this z-score. So we want to copy this and paste it right here. So let's call this z math 1. All right, and then just double click that down. All right, the key though is we don't want it to be V2, we want it to be U2, great band. And then double click that down. So let's go down to the bottom here, delete these, and let's calculate the mean like we did here. And now we have our standardized test score with a mean 0 and 1. So that's how we do that for question number 3.